Circuit Sudoku number 5. This is the only one we're doing on this video. If you want to do this on your own, pause the video right now, maybe solve the whole thing, and then fast forward to the end and see if the two of us agree. All right, here we go. I like to color wires with voltages. All of this has some unique value of voltage. I don't know what that is yet. The bottom portion, only that little guy is 0 volts worth of electric pressure, just him, which means we're going to need some other colors here. All of this region has the same electric pressure, some number of volts of electric pressure. All of this region right here has some value of electric pressure. And finally, all of this region here has some value of electric pressure. And you don't always have to find these, but I like to have them out there at the beginning just in case I need them. All right, well, what do we got here? Sudoku, so you just start putting answers in somewhere. Resistor 2 must be a 9 ohm resistor. 18 equals 2 times 9. What else am I seeing here? I'm seeing 12 amps through the battery. All right, so right there, there's 12 amps flowing through there. That must mean there are 12 amps going through resistor 7. Isn't that right? And furthermore, check out this logic. 12 amps going through resistor 7, 12 amps going through the battery. Now it gets here. Now it splits 3 ways. Some amount, some amount, some amount. Who cares? But what happens right there? Don't they come back together? 12 amps, boom. Through resistor 4, it's got to be 12 amps. You know what? While we're on that part of the circuit, check it out. 12 amps through resistor 4, 12 amps, 12, 12, 12. Now those 12 amps split. And according to our table, 8 of them go through R6. That must mean 4 of them go through resistor 5. All right, see, now we're getting somewhere. 4 times 12, that's 48 volts of pressure difference. 2 times 4 is 8 volts of pressure difference. Across resistor 7, all right, here we go. Across resistor 7, we're told that the pressure difference, and one more time, the top of this table where it says V, it would actually kind of be nice if they put delta V there, because it is a difference in pressure from one side of one thing to the other side, but they usually don't. They just write V, but that is a voltage drop. 6 volts of pressure difference from one side of resistor 7 to the other. Well, it's 0 on that side, so that must mean that the pressure of that region is 6. And according to our table, there's an 8 volt pressure difference across resistor 5, which, first of all, must mean that there is also an 8 volt pressure difference across resistor 6. I can put that in. Why don't I fill in what that resistance must be? 8 equals 8 times what? 6 equals 12 times 1/2. Okay, we got that. Now, this lower right portion of the circuit, we don't have the voltage labeled for that. Can we figure it out? And the answer is yes. Across resistors 5 and 6, you see the table says the voltage has dropped by 8, and it drops from what to 6? 14. And across resistor 4, we're told that the voltage is dropped by 48, which means in this blue region, it must have been 48 plus 14. What's that? 62? That's the color of that wire right there. All right, see how our table helps us? We're told that the voltage drop across resistor 2 is 18. Well, R1 and R3 have those same voltage drops. Across R3, the pressure has dropped by 18. Across R1, the pressure has dropped by 18. And if it has dropped by 18 and it's 62 at the end, then what was it at the beginning? 80. There's the voltage of our battery. This is an 80 volt battery for this circuit. So I'm looking at the current going through resistor 3. It must be 6 amps. All right, what's the resistance perceived by the battery? That's going to be 80 divided by 12, so that's 6 2/3, so 6.67 ohms. Again, this is not the resistance of the battery, it's the resistance that the battery perceives as it's trying to push charge. This battery doesn't know that there are 7 resistors in there. The battery thinks there's only one, and it thinks it's a 6.67 ohm resistor. Now, what do we do with this line? Let's go to currents. We've got 12 amps. Watch my pen here. 12 amps going through the battery. 12, 12, 12 amps, 12 amps, 12 amps. Now they split 3 ways. And according to our table, 2 amps go through resistor 2, 6 amps go through resistor 3, so the rest must go through resistor 1. And that's 4. See? 4 plus 2 plus 6 got to equal 12. And then the 4 plus 2 plus 6 flow back together right there and give you 12 again. So I think we're in good shape. So that's going to have a resistance of 4.5 ohms. All right, let's calculate the power. 960 watts. That's going to be 72 watts, 36 watts. We're doing I times V here. 18 times 6, 108. 48 times 12. Whew, that's going to be 480, 576. And 8 times 4, that's an easy one, 32. 8 times 8, 64. And 12 times 6 is 72. That's all the power that's being consumed by the resistors. Now, what does that add up to? Well, let's see if we can do that. That's going to be 180, so that's 216. So that's going to be 792, and that's going to be 824 plus 4 plus, so that's going to be a 0 and 960. Whoo! 960. There it is. We're giving ourselves a smiley face for that one.